the Drew World Order.
For we are opposed around the world by a monolithic and ruthless conspiracy that relies primarily on covert means for expanding its sphere of influence, on infiltration instead of invasion, on subversion, on intimidation instead of free choice, on guerrillas by night instead of armies by day. It is a system which has conscripted vast human and material resources into the building of a tightly knit, highly efficient machine that combines military, diplomatic, intelligence, economic, scientific, and political operations. Its preparations are concealed, not published. Its mistakes are buried, not headlined. Its dissenters are silenced, not praised. No expenditure is questioned, no rumor is printed, no secret is revealed.
Out of these troubled times, our fifth objective, a new world order.
It's a phrase that I often use myself, that we needed a new world order.
The very word secrecy is repugnant in a free and open society. And we are, as a people, inherently and historically opposed to secret societies, to secret oaths, and to secret proceedings.
As I've told you before, because I love it so much, they also created the Great Seal of the United States. And that Great Seal of the United States has on it, Novus Order Seclorum, a new order for the centuries, for the ages, forever.
A new world order, because the global order is changing again.
But I am asking your help in the tremendous task of informing and alerting the American people. For I have complete confidence in the response and dedication of our citizens whenever they are fully informed. Not primarily to amuse and entertain, not to emphasize the trivial and the sentimental, not to simply give the public what it wants, but to inform, to arouse, to reflect, to state our dangers and our opportunities, to indicate our crises and our choices, to lead, mold, educate, and sometimes even anger public opinion. This means greater coverage and analysis of international news, for it is no longer far away and foreign, but close at hand and local. And so it is to the printing press, to the recorder of man's deeds, the keeper of his conscience, the courier of his news, that we look for strength and assistance, confident that with your help, man will be what he was born to be, free and independent.
Drew World Order.
Dude, I have a question. Can you tell us the difference between DNA and RNA and the functions of each?
RNA is the second stage. It's transcription. So they're just different languages. I mean, chemical languages, but different languages. RNA has still four pieces, still four components. So you have uracil instead of thiacil, where DNA has thiacil. But what will happen in protein production is that RNA will be the first stage of it. Actually, it's the second stage. And then from RNA, it sort of prints out, transcribes into DNA, if you would.
Okay.
So like the three stages, I believe, are transcription, translation, and
replication?
Yeah. You have DNA, right?
Yeah, A, G, C, and T, right? I don't know what that stands for.
GATC, yes.
GATC, okay,
Not
cool.
H.
Yeah,
GATC.
Yeah, okay.
And then you have for RNA, you have GAUC. And RNA is a little more epigenetic in its function. DNA is the actual protein, of DNA. But RNA will be you'll have a strand of DNA, right? Mm-hmm. And the strand of DNA will, let's say, I mean, most of the time it's for duplication, right? So you want to duplicate a piece of DNA. You have transcription into RNA, which is essentially another chemical language. And RNA is a lot easier to replicate for whatever reason. I forget the reason. The code of the RNA is then translated into an actual protein, into a group of polypeptides. So, a single peptide is a peptide, but a string of peptides are called a polypeptide, and those are amino acids. So, and then they'll take a bunch of polypeptides and create protein, and that's protein synthesis. RNA serves as almost like a Rosetta Stone.
Okay.
To translate from DNA to protein.
No shit. So, they're working in tandem then, right? Or is one more dependent? Okay, so as within, so without. In DNA,
sure, I guess so.
Talk about the structure, because that's fascinating too, like the double helix, how it's formed.
Yeah, it's all well spelled out. I'll put up there's a really good YouTube video that shows the stages, but it's really kind of freaky because it looks like it totally looks like machinery. But there is something that looks like an individual protein globule, but it's essentially an individual RNA reader. And it'll read the RNA, and then on the other side of this complex, it is printing out exactly what the RNA is telling it. So RNA is essentially like a script.
Damn.
And these things, the codons will read the RNA and will create an amino acid polypeptide based on what's written, but it's actually just based on the chemistry of the RNA. It'll print out, and then those proteins will have certain polarities, so that everything holding together the alpha helix is a hydrogen bond, which is why if you are creating DNA or replicating DNA, if you heat it up to a high enough extent, those hydrogen bonds will break and then they'll become single-stranded. It'll denature from that alpha helix into a single strand. Once it's in that single strand form, then you can reconnect it, and that's how a lot of DNA replication or changes happen. So
is that where like genetically modified organisms and food and shit like that come in? Is that what they're doing when they are saying they're doing that?
Yeah.
Okay.
So, which is why I always tell people you really the dangers of genetically modified organisms are next to nil. The dangers lie in what can happen to the environment, but in consuming them or eating them, if you're not considering the environmental dangers, are fine, because there's no difference between a protein that's been genetically modified and one that hasn't. It's far more dangerous when they change the molecule itself by chemical means.
So you're saying
because you're still working,
as long as it doesn't have exposure to like pesticides or whatever else, chemicals and shit like that.
Exactly. So I'll give an example of what I mean by it's bad for the environment. So let's say they make a genetically modified organism that is immune to it doesn't absorb pesticides, right? So you can spray this plant with pesticides and the plant will be fine. It'll just kill the stuff, whatever you're trying to kill that's around it, right? If you put in DNA that makes it immune to certain insecticides, you can spray it with insecticides and that's not going to kill the plant. It's just going to kill what you wanted. They don't take into consideration the fact that life evolves. So if you spray an entire field to try and get rid of one insect, 5 or 6 of them are going to be immune. It's almost like the Black Plague. Like the Black Plague wiped out 1/3 of humanity, but a certain amount of people had a dormant, kind of like a latent immunity to that specific bacteria, to the bubonic plague. They had an immunity to it, and so 2/3 of the world survived, and everyone else died. Now, the second round was very different. The second round was then the bubonic plague came about, would have been completely lackluster. No one would have died. Why? Because those who survived had an immunity to it.
That's right.
So that happens in the fields when they spray some type of insecticide. They might get 90% of whatever insect they're trying to kill, but the 10% that remain now have an immunity to it, and they're the ones that survive, and they're the ones you have to worry about the next year. Second of all, those insecticides go into the water, split into insane things. Did you just see the most recent thing that Monsanto is getting sued in a class action suit for that?
That was actually on one of my questions I was writing down here was talk about Monsanto and
No. Monsanto is being sued for weed begun. They found out that it causes non-Hodgkin's lymphoma, and they're getting sued for something like, in the billions, 30, 40 billions. Damn. And it was out there. People knew that it would affect other people. But then again, what I'm trying to say is it's the chemicals that are the issue. It's never the genetically modified organism that's the issue. It's what they use on top of that. It's the chemicals that they use alongside the genetically modified organisms that cause the problem. Never the genetically modified organisms, because all you're doing is changing around DNA. And DNA is DNA. It's just those 4 components. Mm-hmm. Yes, of course, you can change it around to create a poison, but that in and of itself isn't a danger from the actual molecule.
People's anger towards Monsanto is it's geared towards the wrong thing, I think is what it sounds like. Unless shit like this comes up. I found this article. Complaint alleges that Monsanto and BASF sold formulations of dicamba as part of the scheme to force farmers to defensively plant dicamba-resistant crops.
Exactly. So what you're seeing there is not making a claim that the genetically modified organism is in and of itself unsafe for the consumer. What they're saying is that the tactics around how they're using the genetically modified organism is making it so that the environment becomes unsafe for or an unfair advantage towards Monsanto against a small farmer. It's not the actual genetic modification that's the issue, because it's just using DNA.
And the next article down is the rising monopoly of Monsanto. So that actually ties in nicely with what you just said there. Does Bayer and Monsanto are owned by the same company, or does Bayer own Monsanto?
Bayer bought out Monsanto because Monsanto is equivalent to it saying Nosferatu at this point, genetically modified organisms. They took every route they could to fuck over the little farmers. Okay, I'll give you a perfect example. People were very scared when they found out that Monsanto created a lettuce that had incorporated gene from a scorpion, so nothing would eat the lettuce, right? So no bugs would eat the lettuce. On the surface, just hearing that is kind of freaky. Fact is that the poison from that scorpion was not harmful to humans. There was no taste, there was no smell, there was nothing affected humans whatsoever. It was only affected a very, very specific bug, right? Because this scorpion was evolved to just be able to take out this specific bug that was eating the lettuce. And people freaked out just hearing the fact that that the word scorpion was involved with their lettuce. But literally no danger whatsoever.
That's the power of the headline right there. All they read is the headline, fucking scorpions in my lettuce,
Right, exactly. People are thinking that, scorpions are going to come out, jump out of their lettuce. Only this thing. Another one, most people don't know, 90% of the tomatoes that you buy right now, fish genetics in them. Mm-hmm. And they have fish genetics. They have a certain gene from fish that allow fish to not freeze when they're in freezing cold water. And so tomatoes, if you freeze a tomato, it comes out it ruins the consistency of it. Mm-hmm. So I would say almost all tomatoes that people buy from a store, if you're not buying, unless you're buying, non-GMO tomatoes, have this fish gene in it. Now, do they smell like fish? Are you going to be allergic to it if you have a fish allergy? No, not at all. Mm-hmm. Because a very, very specified gene was pulled from it and placed into the. A lot of it is just a misunderstanding.
Remember the movie X-Men: Days of Future Past? Seriously, hearing you describe that reminds me of Bolivar Trask when he's trying to replicate. Was it Mystique's power or whatever?
Yeah,
man, it just reminds me so much of that. This article, Monsanto had filed 144 lawsuits against family farmers, and settled 700 cases out of court between 1997 and 2010. That's a lot of fucking cases.
They applied for patents for their seeds. So even if their seeds,
that's right, yeah.
Even if their seeds, blew over to the next farmer's land, they could sue the farmer. And they paid the price. there's a few sad stories about it too, where Monsanto had in Africa, malnutrition in America and malnutrition in Africa take on very different forms. In Africa, it takes on the form of people being born, being on average a lot shorter, sometimes lower intelligence, lower muscle mass, lower bone density, because they don't have the right vitamins necessary as they're growing. And so Monsanto created, because most of the people in Africa have usually just one staple crop that they eat, and that's what they eat, and it's the only thing they eat. And so Monsanto had created, in one of these countries where they would eat only rice, Monsanto had created this rice. It was called golden rice. You can look it up. And it was incorporated with the vitamins that they were missing the most. I believe it was vitamin A, vitamin maybe K. Yeah, and it gave it this golden color. But because of how Monsanto had been seen across the world, the people there freaked out, didn't allow it in. And that was a really sad thing, because it was a perfect solution to a problem that still persists. And it would have cured, the entire country of malnutrition, and would have been useful for many other places. And Monsanto had created this, and we're giving it to them for free. But because of Monsanto's rules that they can only buy it from them, et cetera, they were worried that the same thing was going to happen there, and that it was going to ruin their crops without really knowing what they were turning away. They were turning away a solution to malnutrition for the country.
They did. They provided royalty-free licenses to speed up work on a genetically modified rice that could alleviate vitamin A deficiency around the world.
Yeah, they gave up the royalties. So people were just able to use it. They were going to be able to sell it and spread it. They were in the act of trying to, fix their name. Spent $1 billion probably. At that point, CRISPR wasn't around. The most advanced genetic editing tools were super, super expensive, very expensive. This editing tool called Talons was what Monsanto was using at the time.
Huh.
And it just fell off, it just never made it off the drawing board, because people literally took to the streets and went crazy and burnt the seed.
Really?
Monsanto brought them.
Wow.
Yeah, man. It was a big deal. I think it was in Senegal. I'm not certain, but I think it was in Senegal.
It's not an American company, is it?
Yeah, sure it is.
It is?
Yeah, they're Southwest. Okay. But now Bayer owns it, and so have a much better view of Bayer, but they'll ethically change a lot of things. The sad thing is that it's not the technology, and people have a tendency to look really down on GMOs. But I'll tell you what, over the next 10 to 15 years, absolutely are going to have to change that mentality of GMOs are dangerous and can kill us. If somebody can show me any peer-reviewed study on how GMOs themselves, again, not how they affect the environment and not how business tactics affect the outcomes, but GMOs themselves, just the technology itself. To me, it's the equivalent of saying that fire is bad because houses can be set on fire. It can also be used appropriately, properly, and do a lot of good.
Well, you make a good point, because in 1970, the world's population was 3.686 billion, and 2017, 7.53 billion. There are not, we got to feed these people. Malnourished. We got people that are like obesely malnourished. I don't even know how.
That's the flip side. I was watching some TEDx talk showing malnourishment around the world and showing the differences in malnourishment. And it's really stark to see, in Africa, we're trying to, malnourishment takes on a very different, it takes on the classic idea of malnourishment, malnutrition, where, people are underweight and low vitamins during pubescence leads to, people not growing as much, their brains not developing as much. And in America, it's completely the opposite. It's high levels of diabetes, obesity, and all kinds of things that are on completely the other side of the spectrum is still classified as malnutrition. It's almost like the excess of nutrition or the excess of food.
You have to wonder, what the fuck is it going to take? I hate the thing. Less sad either. It's getting more and more crazy.
No, it's getting worse, man. I work on the ground level of remediation, and they just added this new chemical. Oh my God, dude. Go watch this documentary. It's called The Devil You Know. It's about this group of chemicals called PFAS, PFOAS, or PFOAs. And in 1940, they didn't exist. Now, there has not been a human being tested in the world since 1955, maybe, that didn't have levels of PFOS in their blood.
No
and
shit.
It's a really, really widespreading surfactant. So it sits on top of the water. It spreads very easily, and it is everywhere, and it is highly dangerous. And only now have they passed the levels that a place has to be below. But before this year, no one was even looking at this. This could be in your water up until this year, and you would have had no idea. And the effects, if you watch The Devil We Know, these companies went into it knowing it. DuPont, 3M, right? And DuPont knew what it did, dude. They knew what it did, and they still released it. And they're getting sued really, really hardcore. It's very interesting because it's the first time that a class action lawsuit came together. It's hard to explain that. I don't want to hijack, but just watch that, dude. And maybe if you watch it and you want to talk about it, I'd be willing. But it's a really cool documentary. The class action lawsuit, everybody gave the money from the class action lawsuit to pursue further, to hire the scientists necessary to like what is still the world's largest case study to prove that DuPont knew about it. And DuPont, if anybody's a trader out there, like a stock trader, go out there and sell DuPont short because they are fucked. They're losing individual lawsuits of like 7 to 9 million on average.
Damn.
And that is a huge
individual lawsuits.
Individual lawsuits.
Into 7 to 9 million.
Yeah, and normally people get what, like 10, 15,000, something like that.
Yeah.
From class lawsuits. So the only reason that happened is because they had the class action lawsuit, and everybody who was part of the lawsuit, if they would have accepted the money, if those first initial people would have accepted the money from the class action lawsuit, DuPont would have gotten by, positive in the billions, because they wouldn't have been the case study wasn't large enough for them, for the government to say, okay, this was definitely DuPont's fault. So everybody in the class action lawsuit gave up their bit of money to pay for the scientists to actually do like a comprehensive study over 10 to 15 states. South Carolina just passed it. They had one of the biggest facilities out there. And so people are suing them left and right and walking away with big fucking chunks. Thanks to the people, thanks to the initial people who gave up.
That's a rare thing right there,
Yeah, people never do that, dude. That's one of the first times that it's been done.
Absolutely. Hashtag what the fuck?
Well, I mean, right off the back, structurally, it can work, right? Because it's just hydrogen bonds. So any radio waves or anything would fluctuate the hydrogen bonds, but that would be super complex to make, I would imagine. Because it's DNA, it would have a change from anything that heat or anything, radio waves, any type of wave, sound waves would fluctuate the DNA because hydrogen bonds are almost liquid in a way. If you look out at how DNA is pulled together, you would be able to read it in the same way that, you can read things from light, The reason why you can read things from light is because it's structured, and you can have, 0 and 1s very easily incorporated into photons, You can have, or it's essentially Morse code for light.
DNA, though, is strictly, what does light do to DNA? Is it strictly sound waves that are altering?
No, light changes DNA.
Okay. Sure. I was going to say.
But in it's a haphazard way, the way light changes DNA. Like it's not known, it's not directly known how it'll affect DNA, but radio waves affect it in a very specified way.
So what about?
I'm not certain, but I'm just thinking off the top. I have no idea. I've never heard of it or know whether it'll work. I'm just thinking off the top. The way hydrogen bonds work.
What about 5G? What do you think that impact on DNA will do?
I don't think it could have a good impact. Now, that's not to say that I think it can have a bad impact, but I would lean towards it having a bad impact, to be honest. I'm not certain, but I mean, 4G has an issue. Radio waves affect DNA. And there's a 1 in billion chance that it fucking creates, 1 in trillion chance probably that it creates something carcinogenic in your DNA or has like a change. But radio waves affect DNA. DNA can be easily affected by any type of radiation, and radio waves are a type of radiation, that DNA pulls in these types of waves, sound, radio, X-ray, photon by DNA, or get absorbed by DNA and have some type of fluctuation. So it would make sense that 5G would be detrimental to DNA.
From the point you just said, that process, like where, because I've heard scientists and I've read articles about how it's possible you can reprogram DNA. Would that be before that process or after?
Probably during. I mean, at any time your DNA is changing. It changes through random fluctuations. It changes through things you eat. If you have something that has polarity is important, like chemical polarity. So if you have something that has like a free radical, I'll give you a good example, pepperoni, right? Pepperoni has nitrates. And when they mix in your stomach acid, they create a lot of free radicals. The free radicals are just essentially electrons that are on their own that have been separated due to some kind of process. And in nitrates, free radicals are formed. When they hit something, when they hit a piece of DNA, it brings in a negative energy, like an electron-based energy, and that shifts the DNA in some way. I would guarantee that 99.9% of the time the DNA can absorb it, and the changes are inconsequential. Most DNA is junk DNA anyways. Affecting something negatively is very, very slim. But over the course of your lifetime, if you're surrounded by it, right, you're allowed a certain amount of radiation, direct radiation, like alpha, like beta particles. You're allowed a certain amount per year, right? You go and you get an MRI, you're getting pounded by beta particles at that time. But it's more about, and a lot of people don't tell you that, look, the reason why we say, you should only have, one MRI, so every so often is not because that's how long it takes for your DNA to get fucked up, but it's just minimizing the chance. The fact of the matter is you can have one MRI and get fucked over. And it just so happens to hit the right spot. But it's just a numbers game, that's the way quantum works. It's just a numbers game. So the more you're exposed and the higher the radiation you're exposed to, and chance of it affecting you negatively. What would you say? It's just concentration over time, So if you increase time or you increase the concentration, both increase your chance of having a deleterious change in DNA.
How does emotion affect DNA?
All right, so emotions release certain chemicals. One of the most notable being cortisol, right? A negative emotion. Positive emotion is going to release dopamine and serotonin and other chemicals that have positive effects on you. But cortisol, leaves a free radical. Cortisol and also lactic acid moving around your body, hitting different parts of DNA, different areas of DNA, probably your blood, first of all, maybe transferring like in the lymph nodes and things like that. Cortisol is really bad for you and affects you in a very negative way. And lactic acid also. Lactic acid, if you're in like a fight or flight mode, or you're upset, sad, nervous, it would affect it in any other way that a free radical would. Acids have free radicals and they're in constant flux, changing from, so if you have water that's high acid, you're having high levels of H plus and high levels of OH minus, right? Which each of them has a free radical. If those can break through the barrier of a cell and enter the nucleus and hit, have that free radical hit a piece of DNA in just the right spot, it could
fuck you up in a lot of the ways that any other type of acid would. Oxidation and reduction, like oxidative properties of those negative chemicals that your brain puts out, neurochemicals, like serotonin and dopamine, would have a dangerous effect.
Honestly, you're the most qualified person I've been meaning to ask you these questions. I'm sitting here taking notes like it's biology class.
NCBI is a really, really great website. And you'll always be able to
NCBI.
NCBI, like the National Center for Bioinformatics, I think, or Bioinformation. They have my go-to for any of this type of information. But if you just look up like cortisol effects on DNA, you'll find they even have like meta reviews where people will take 300-400 papers that were on the same topic and then do analysis to those results and find like meta results. You know what I mean?
Yeah.
And those are really interesting. Those are really interesting when you find like the meta reviews of maybe the last 2 years of data in a certain.
You mentioned the fight or flight. Talk a little bit about that, because I mean that's the reptilian brain, right? The R complex, your survival instinct.
Right, exactly. So the original question you had was what?
Sound, or what was it? Emotion and sound and light play into
right. Emotion. You have really, if we had to categorize it, you have good and bad emotions, right? Let's just, for simplicity, let's put it there, right? Let's just say that, or let's say this: emotions either positively or negatively affect you just on a human level, right? Just in your brain. Now, when that happens, you have a cascade. Let's say they affect you positively. You have a cascade of neurochemicals that are released from that. Some being, your reward mechanism for doing something that your brain approves of. And so you have dopamine hits and you have serotonin hits. And those chemicals have positive effects on your brain, just the way that the structure of that, the way that chemical is built. You have a flood of GABA. You have a flood of GABA when you're calm. On the flip side, when you have a negative emotion, when you're scared, when you're nervous, your body releases adrenaline. Your body releases cortisol. It releases lactic acid from fear or from the idea of flight. So when you have these negative emotions, they prepare you, kind of like your lizard brain for an attack. So you get into a fight or flight mode, but your body, it beats up your body. So if you look at the effect of being in that sort of state of fight or flight constantly, you have an increase of cortisol releasing, which if you look at the chemical and how it affects muscle mass, how it affects your stomach, it affects it very deleteriously. The chemical itself has a polarity that if that free radical hits, DNA is almost always in a it's in like a castle, right? It's inside the nucleus of a cell that has like a moat surrounding it and has all these kind of things that are there to protect your DNA. But every once in a while, the situation just lines up perfectly that these free radicals can get in and affect it. And so the fight or flight mechanism leads to chemicals that can have a negative effect on your DNA. There's a low chance, but I'll tell you what, if you're in a negative state of mind, often throughout, 20 years of your life, you're going to be releasing this lactic acid. You're going to be releasing a lot of cortisol. You're going to be building these neural pathways to the release of cortisol. These areas are going to strengthen up. And over time, you're going to increase the likelihood to have a deleterious DNA change.
Dude, that was okay. So what you just said, I think, is very, very important to everybody. And if you wouldn't mind, say it again, because that fucking really hits home. If I can give the best advice to people about, winning your mind over, having a good perception, and he just said it, Josh just said it.
Yeah, you can go right here and see this. This is literally called the impact of lactic acid bacteria on oxidative DNA damage in human-derived colon cells. So reactive oxygen species, that's anything oxidative. You have redox reactions happening all the time in your body. And if you have something that has a high polarity, so if you have a molecule that has they can be directionalized. Like it can have a positive end and a negative end, and those will pull towards the opposite, right? And so in DNA, the hydrogen bonds are positive and they are linked to each other, but you have something strong that has a very, very strong, you have a molecule come in that has a strong polarity. It can absolutely pull apart the DNA and have a very negative effect on that DNA. That strand of DNA is then inside your nucleus, will get replicated, and most of the time, 99.9% of DNA changes are to the junk DNA. But if on off chance it affects something else, if on an off chance it creates a change that leads to a carcinogen, this is how cancers are born.
Mm-hmm.
This is exactly how cancers are born. And when people like, I have no idea why this happened. You know, I lived a perfect life. I didn't smoke. I didn't do this. It was just random chance. Oxidative reaction happened in a cell inside of your DNA, and it presented it in this way. But if you read the abstract in this, you'll see the link between colon cancer and lactic acid.
That's right.
And lactic acid is absolutely released when you have fight or flight, which is absolutely released when you're nervous, when you're scared, when you're beating yourself up for something that you wish you could have done. These type of thoughts have a direct correlation to your body in a very physical way.
So I got two questions from that. So that means it's extremely important if you go work out, run, do anything to stretch and to break up that lactic acid following a workout.
For sure.
Yeah,
for sure.
So, yeah.
When you're working out, that lactic acid is usually centered in your muscles, and that's a fairly safe place for lactic acid to be.
Okay.
Again, you could work it out easily, but your muscle cells are pretty freaking strong and have very, very strong, cellular walls, sort of like your skin. Your skin has, your skin is bombarded with photons and all kinds of things. A little tiny bit of bleach spills on there. That shit is extremely oxidative. But your skin cells have a very strong, thick outer cell wall that keep things from getting inside. So you're fairly safe on that. But I'll tell you what, somebody who's a cleaner, who cleans houses and uses bleach and doesn't use gloves over 40, 50 years, you're damn right they're going to have issues with their hands.
Mm-hmm.
And if it happens to work itself and hit a blood cell that travels around and that happens to bounce off, again, it leads to excess energy. And that excess energy, if that happens to strike the right piece of DNA at the right time, that's it. That's all it takes.
Excess energy.
Yeah. So if you have a lone electron, you have this excess energy that is polarized. It's polarized in the negative. So if there's something positive that has a polarity in the positive, that electron will get pushed towards it. And when that moves, it's a cascade effect. You could look up the electron transport chain. Electrons are also what powers electricity. I mean, that the flow of electricity is the flow of electrons through a circuit.
Mm-hmm.
That's all it is electrons flowing over metal. And therein lies the study of electrodynamics or electromagnetics. But that is what electricity is. The result, it is electrons just moving over a metal circuit.
So you mentioned the pH consistency.
It depends on the cancer. Some cancers are cut out for it. Some cancers will release alkalinity. So dude, cancers are fucking nuts, man, because they're so specific and they're very specific. They're even specific to the person. I think there's something and this is just what they've identified. They've identified something like 40 different types of lung cancers. Cancers that not I've seen, but I've watched videos about of cancers that are stuck in the adrenal glands and are just secreting just because of the way that the DNA got changed in that specific person and that specific cancer. It's secreting adrenaline. And so this person is hopped up on adrenaline constantly, and they couldn't figure it out for a long time. And eventually they identified that stop this secretion of adrenaline. Some cancers will literally just like put out their own antibodies. And so cancers we give them, it's almost like saying itis, or like almost like saying the disease. Cancer is akin to saying that, just because there's so many different types and chances, and it's unique. You could Google CRISPR right now and order a line of CRISPR and work on it in your own house. If you built a laminar flow hood and had some, good glassware, you could be working with CRISPR right now. It's like $75 to buy some specific CRISPR lines.
Yeah, there is. There's some for sale here.
Yeah, dude, which is scary. Because someone with the right information could be making fucking Spanish flu.
Well, yeah, here's a micro GM DNA extraction kit from $108. Oh, here's a CRISPR thing for $350.
That's probably a new line. What line is that?
CS9 assay ELISA kit, colorimetric. Your background on this, like, because obviously you know what you're talking about. Like, it's no doubt. You're very knowledgeable.
Yeah. I mean, I'm part layman in CRISPR, but I do have my degree in biology, and
that's right. Yeah.
The last semester, I was doing chemical engineering before that, which sort of goes hand in hand. Chemical engineering sort of teaches you how to build the plants, literally build the processes that to work on a large scale to make whatever chemical you want. A lot of chemical engineering is like heat and mass transfer. Biologically, I switched to biology, and biologically I learned how to work with cellular and molecular was my concentration. Specifically for plants, it was almost all CRISPR. I was taking master's classes, and it was all peer reviewing CRISPR, working in the laboratory with CRISPR, because everybody went crazy. As soon as they figured it out and saw the potential that CRISPR has, every school that I know. It's honestly, right now, a lot of people don't realize it, but it's like the space race times 1,000. It's like the Industrial Revolution times 1,000 happening right under our noses. And a lot of people don't know about it. Dude, I know you like to dig into that shit. You can totally dig into CRISPR.
CRISPR, right?
Yeah, CRISPR.
Dude, what's your dream job?
My dream job, there's this really cool company, dude. Look up Memphis Meats. I would like to be doing something like that, where they are right now making meat from cell culture. So it sounds gross to a lot of people. They're like, what? You make it in a vat? And it's like, yeah, almost the exact same process that you use to make beer, they use to make meat.
All right, Bridgewater steps up to the plate. He's a 233 season average. He's 0 for 2 today with the ground out and a pop-up. Also, he told the manager to go fuck himself. First pitch, he's a little bit inside, ball one. Now, Bridgewater coming over from San Diego in the off-season. He had a little bit of a thyroid problem, and he's been ejected. There you go. So we've played 5 games this year. So far, people, he's been ejected from 7. You do the math on that. All right. Hayes is next batter. All right, 1 out. We're at the top of the 3rd inning here. We got the fuck dolls in the Who Gives a Fucks face-to-face at Sphincter Field here in beautiful, sunny northwest Kansas, Goodland, Kansas. Who the fuck brings a Major League Baseball team to Goodland, Kansas? What the fuck were they thinking? Well, that's none of my business.